Good morning, students. My name is Samuel Chukwu Emeka. In this video, we shall discuss the United States Customary System compound units. The U.S. Customary System compound units. And we shall specifically talk about the simple compound units. The video is broken down to simple compound units and complex compound units. In this particular one, we shall deal with the simple compound units, and I shall explain to you what it means. Now, what do we mean by compound units? Let's talk physics for a little while. Okay, let's talk physics. We have what we call the fundamental quantities and also the derived quantities. We have what we call fundamental quantity and derived quantity. Fundamental quantities are those quantities that cannot be derived from any other quantity. Something like length, mass, time, temperature, and so on. Derived quantities are quantities that are derived from the fundamental quantities. Derived from the fundamental quantities. Some, for instance, for example, speed. Speed is length over time. That's distance over time. Rate of change of distance with time. So you see, the distance, which is the length, is the fundamental quantity, and the time is also fundamental quantity. When we divide distance by time, we now have a derived quantity, which is the speed. Another one, look at the pressure. Pressure is a mass over area. We have mass. Mass is the fundamental quantity. Then area is a derived quantity from distance. Area is distance times distance. Then when we combine these two, when we divide the mass by the area, we find another quantity, pressure, which is also a derived quantity. So we can find these derived quantities either by division or multiplication, but it has to involve some fundamental quantity. At least it has to involve at least one fundamental quantity to get a derived quantity. Now, we talk about the units. When we talk about fundamental units are the units of fundamental quantities. Like the unit of length. Of course, in the U.S. customary system that we are talking about, we have a inch, feet, miles, and the rest of them. Then the mass, we have the pounds, and the rest of them. The time, we have the minutes, the seconds, and the hour. Okay, those are fundamental units. Now, derived units are something like, for the speed, we have the miles per hour. For the pressure, we have the pound per square inch or pound per square feet. So the derived units are the units of the derived quantities. Those derived units are what we are referring to as the compound units. Okay, those derived units. That is, those units that are derived from the fundamental units. Okay, and those units must be derived from at least one fundamental unit. For instance, let's look at the miles per hour, which is the unit of speed. We derive miles per hour from the miles divided by the hour. So distance divided by the time. The miles is a fundamental unit. The hour is the fundamental unit. So when you do the division, it gives you the derived unit, which is the compound unit. When we talk of area, for instance, it is a length times length, which is a miles times miles, square miles, or we can say square inches, inches times inches, or square feet, feet times feet, square feet. So you see that the two, in this case, two fundamental units are being multiplied to give the derived unit. If it was the speed, miles per hour, you see two fundamental units are being divided to give the derived unit. If it was the area, feet times feet, square feet, we see that two fundamental units are being multiplied to give derived unit. So it can also involve a fundamental unit and a derived unit, like pressure, mass over area, right, which is pound per square inch or pound per square feet. In this case, the pound is the fundamental unit, and then the square inch or the square feet is the derived unit. So when we talk about compound unit, okay, or derived unit, it involves at least it involves at least the multiplication or division of at least one fundamental unit. Okay, at least one fundamental unit. It could be one fundamental unit and one fundamental unit, or one fundamental unit and one derived unit, or two fundamental units, or two or more. But at least it involves at least one fundamental unit. So that is the idea now. Compound units are the derived units from the fundamental units. And why are we learning this? We are learning it because we use it in life. You know, sometimes we have, of course, we talk about speed, so miles per hour. So we talk about pressure. Yeah, this is something we use in life always, in our basic real world activities. So we are going to learn how to convert from one compound unit to another compound unit. In this video, we are going to focus more on the simple compound units. What do I mean by the simple compound units? We will be given two units, and we will just have to convert it to another unit, but we're going to change only one unit. Okay? As we do examples, you will understand what I'm saying. Okay. Examples. Express each simple express each simple compound unit as shown. Round each answer to the same number of significant digits as the original quantity. Okay, this is the direction for all the examples we will solve in this video. Now, question 1, 61.3 miles per hour to miles per minute. Okay, now what I mean by simple compound unit is that, you see, we are given miles per hour and we are told to convert to miles per minute. So only one unit would change in this case, right? We are given two units, but only one unit would change. The miles does not change, but the hour would change to minute. We have to convert the hour to minute. So how do we go about solving this question 1? We are going to use of course, we can use a method of proportion, and also we can also use the unity fraction method. But I'm going to use the popular method, which is the unity fraction method. Yeah, that method is a lot more popular and a lot more time consuming. So how do we write this out now? We write 61.3 miles per 1 hour. Now, if we have a 61.3 miles per hour, per hour, per. And now some of you might say, what am I saying? Per. I'm sorry, this is what I'm saying. Per. You know, I have an accent. Per hour. Okay? Like, let's say you go to the store, let's say you go to Walmart, and you see maybe 5 per, 5 for $2, that's 5 per, I'm sorry, 5 per $2. That means for every $2 you get 5. Okay, if you see 2 per $5, the pair is usually like this. Okay, maybe let's say you see 2 per $5. You go to Walmart and you see 2 per $5. So that means for every $5 you get 2. That's what it means. If you see 5 per $2, that means for every $2 you get 5. Okay, so that is what it means. Now, if we have 61.3 miles per hour, that means for every 1 hour we are covering 61.3 miles. Okay, for every 1 hour time interval we are covering 61.3 miles. We are covering a distance of 61.3 miles. For every time of 1 hour, we are covering, the distance covered is 61.3 miles. We are covering a distance of 61.3 miles. So that is what per means. Okay, so this means 61.3 miles over 1 hour, because this is now per hour, right? Now, if they wrote per 2 hours, then they will put 2 hours. Then that means, that will be different. But if they just write it like this, miles per hour, that means for 1 hour. Okay? So, we now have to multiply this by, now, we have to now keep the miles. Okay, we keep the miles because we are not going to convert the miles. It should be as it is. But the hour is a problem. So we have to write hour here so that hour will cross out hour later on. Now, but we want to now change the hour to minute. So we now have to write minute here. Okay? So we now ask ourselves, what is the relationship between hour and minute? We see that 60 minutes make 1 hour, right? So our hour will cancel our hour here, and then we have 61.3 divided by 60. And if we round it up to the same number of significant digits as the original quantity has 3 significant digits. So when we round it up to that, we have 1.02. Now this is now miles per minute. Okay? And this becomes our answer here. Okay? Question 2. 7.024 pound per square inch to pound per square feet. So we now have I probably skipped this at the beginning. Now, the prerequisite for this video is that you will know the conversion. Conversion in the United States customary system for linear measure, for area measure, for volume measure, for capacity measure, and so on. Please, that is the prerequisite for this video. Okay? Alright, let's do question 2. We now have 7.024 pound per square inch. So this is 1 square inch, right? Now we wanna keep the pound like it is, but we now have to convert the square inch to square feet. So this square inch should cross out here. We put it on top, and then our square feet we now put below because it's per. That Then you ask yourself, what is the relationship between square inch and square feet? We see that 1 square foot is equal to 144 square inches. Now, square inches crosses out square inches, and then when you multiply this, you now have, and the original quantity has 4 significant figures. So, when we convert our answer to 4 significant figures, we have a 1011 pound per square feet. And this becomes our answer. Question 3. 2,150 revolution per minute to revolution per second. Okay, so this is a 2,150 rev per 1 minute times. Now we want to keep rev as it is, so we won't touch it. But we want to change minutes. You know, what do you want to keep? Don't touch it. Okay, what you want to keep, that's the way this method works. What you want to keep, don't touch it. Just change what you want to change. Just touch what you want to change. So minutes, we want to convert minutes here, so we put minutes on top. And then we want to convert this to seconds. So then we ask ourselves, what is the relationship between seconds and minutes? We see that 60 seconds is 1 minute. So this minute will cross out minute. And then we have a 4 significant digit in the original quantity. I'm sorry, 3 significant digit in the original quantity. So this will now be 35.8 rev per second. And this is now our answer. Question 4. $1.79 $1.79 per gallon to $2 per quart. So we now have $1.79 per gallon. So this means that 1 gallon costs $1.79. That's what it means. That 1 gallon costs $1.79. So times, now we don't want to, the dollar should be the same, the dollar, so we don't touch it. But the gallon here, we want to cross it out, and then we want to convert it to quarts. So we ask ourselves, what is the relationship between a gallon and quarts? We see that 1 gallon is 4 quarts. 1 gallon is 4 quarts. So this gallon will erase this gallon. And then we have 3 significant figures in the original quantity. So this will now be 0.448 dollars per quart. Now, always make sure you put your units. It's very important now. Okay? Now, I know that, you know, we don't have 0.448 dollars per quart. I know that the American system for the cents should be only 2, you know, but we are looking at the question now because it's 3 significant figures, 3 significant digits. That is why we want to leave it like that. Of course, if it was in the American system, the cents is only 2 digits, so which is actually 45 cents. 45 cents, okay, per quart. But, you know, we just got to leave it like this because we want the answer to be to the same number of significant digits as the original, okay? If you look at this question, the answer we got, which is about 45 cents per quart, it kind of makes sense, right? Because when you look at the fact that 4 quarts make a gallon, And for a whole gallon, a whole gallon is $1.79, right? When you think about 4 quarts, you multiply that by 45 cents, and it's gonna be approximately is about $1.80. Very close to $1.79. I mean, it kind of makes sense if you look at it, like, okay, that a gallon is $1.79. So, and of course, a gallon is 4 quarts. So 4 quarts is $1.79. So what will 1 quart be? 1 quart will now be about 45 cents. This per quart means per 1 quart. So kind of makes sense, right? If I speak like an American. Question 5. 0.260 feet per second to feet. So this will be 0.260 feet per second, 1 second. Now we don't. This is feet per hour. So feet does not change. We don't wanna. Change it. Change the feet. But now we look at second. Do we have any direct conversion from second to hour? We really do not. I know that 3,600 seconds make 1 hour. But what if you don't want to do it directly? That means we have to pass through minute. Okay? If we don't want to do directly seconds to hour, 3,600 seconds to make 1 hour, then that means we can also pass through minute. Seconds to minute, then minutes to hour. So in this case, we want to pass through minutes. So the way we will set it up, we want the seconds to cross out, and then this is minute, then minute to hour. Okay? Now, this is whereby you don't want to go directly from seconds to hour, right? Okay, so we now ask ourselves, we set it up this way so that seconds will cancel seconds and minutes will cross out minutes. So you ask yourself, what is the relationship between seconds and minute? We see that 60 seconds make 1 minute, and we see that 60 minutes make 1 hour. So seconds will cross out seconds, minutes will cross out minute, and then when you, of course, we have 3 significant digits in our original. So when we multiply that, we have 936 feet per hour. And this becomes our final answer. Question 6. 0.550 pound per cubic inch to pound per cubic feet. So we have a 0.550 pound over 1 cubic inch. Okay. Do we have a direct relationship between cubic inch and cubic feet? Yes, we do. So we won't touch the pound. We keep it as it is. Now we put cubic inch here, and here below we put cubic feet. So what is the relationship? We see that 1 cubic feet is 1,728 cubic inches. Cubic inch cancel cubic inch, and when we multiply and leave our answer as the direction says, we have 950 pounds now if you look at this case, some people saying 950 pounds per cubic feet. Some people may want to express it this way. Actually, the answer is 950.4. But if you write 950, that means this is now 2 significant digits, right? And the question is 3 significant digits. So In this case now, whereby you're kind of stuck on this, like, the question is 3 significant digits, and here you have 2 significant digits. Now, if you leave this like this, that is okay. Or if you want, you can also write it 950.4 pound per cubic feet. Now, let me explain this. Okay, if you look at it in a way that 0.550 is also the same thing as 0.55, then the question will give you 2 significant digits. And in that way, 950 is correct. If you insist on the fact that, okay, let's follow what the original question says, is 0.550, and, if you leave it as 950, then that's 2 actually. The second one is 4. Okay, that becomes a problem. None of them is 3, right? And if you decide to round, in this case, 4 is less than 5. It's not greater than 5. So you can actually, if you round, it will still give you as 950 pounds per cubic feet. So because of it, whichever way, I would prefer to use 950 pounds per cubic feet. Some instructors may, if you put 950.4 pounds per cubic feet, some instructors may still give you the grade. Because, this is kind of a confusing situation. Yeah, but I would go with 950 pounds per cubic feet. Okay? Question 7. 0.16 short ton per square inch to pound per square inch. So we have 0.16 short ton all over 1 square inch. Now, look at this problem. Other problems we've been doing, we didn't have to change the numerator, the units of the numerator. But in this case, yes, short ton to pound. So we have to leave square inch. So, like I said before, whatever you want to change, then that is what you use. If you don't want to change anything, leave it. So, square inch, we will not change it. But short ton, we're going to change it to pound. Now, in this case, okay, our short ton, for us to change it to pound, we will have to write our pound in the numerator and then our short ton in the denominator. Now, do you realize how this question is now? It's different from what we've been doing. What we've been doing in other questions, we are changing the denominator unit all the time, and but in this case we are changing the numerator unit. So look at it now, that the numerator unit, we have to now write it the short ton under as the denominator. Okay, just take note of that. So we see that 1 short ton is equal to 2,000 pounds. 2,000 pounds. So short ton will cross our short ton, and we now have 320 pounds per square inch when we leave it in the same significant digits as the original. Okay? Question 8. 538 cubic inches per second to cubic feet per second. So this is 538 cubic inches per 1 second. In this case also, we have to change only the numerator as well. So this is cubic inch. That's the numerator unit, the unit in the numerator. So we have cubic inch here and then cubic feet. Okay? So this will be, we see that 1 cubic feet is 1,728 cubic inches. Cubic inches crosses out cubic inches. We now divide, and then we'll have 0.311 cubic feet per second. Question 9, last but not the least, 618 cubic feet per second to cubic feet per hour. So this is 618 cubic feet per 1 second. Here, as usual, we are not changing, here we are changing just the denominator unit, second. Now, but we don't want to go directly. We want to go from second to minute and from minute to hour. So this will be second, this will be minute, times this will be minute, and this will be hour. Put an hour here. So 60 seconds, 1 minute, 60 minutes, 1 hour. Second crosses our second, minute crosses our minute. So when we multiply, we have a when we multiply, we have 224,800. But this is 3 significant digits. So we will have a 2,220,000. 2,220,000 cubic feet per hour. And this becomes our answer. Thank you so much, students, for listening. If you have any questions, please ask them in class, or just you can, if you're not my student, you can ask it in the comment section. Thank you so much for listening to this video. I hope you understood it. Now, the next video I will do is the complex compound units. Have a great day.